Now let us first discuss regarding distance. Alright, now as you people can see in our 3D model, okay, what we have here we have a pathway and a car which is going to move. So note down the initial position which was on the left side, right, and the car has stopped in the right side. Now here, as you can see students, distance is the total length of the path followed by the object throughout its entire journey, right? So it's the total length of the path. Let me show it to you here, okay? Firstly, it started from here, this point. This was the initial point, right? Isn't it? And the car traveled like this, and now this point is the final point, right? So distance is the length of the path followed by the object throughout its entire journey. So it is the sum of this length, and also this length. Got it? Alright, let me erase this, which the marks that I have made earlier, so that it will be properly visible. Alright, so the distance is the length of the entire path followed by the object throughout its entire journey. Now, what is the difference between distance and displacement? What is displacement now? Let us talk about it. Now, we have a similar model here. Now, you can note down the initial position and the final position. Let me note it down again. Let me note down the initial and final position once again. Okay, and this position is the final position. Right, now the car started from here. Again, this is a similar model, right? The car started from here, it made an entire roundabout and it arrived at, let's say for example, this is point A and this is point B, right? Now in distance what we had, the distance was the total length of the entire pathway covered by the object or covered by the car in this case, right? Let us play the animation. Now, in case of displacement means it is the shortest path. It is the shortest path between the initial and final position. Okay, it's the shortest path. Okay, displacement is the shortest path between the initial and final position of the object, right? Now let us have an activity where we will easily be able to understand the concept in a much better way. Alright. Now here in this model we have Olivia who is out for a jog, right? And we have two parameters here, distance and displacement. Now on the top left corner, as you people can see, we have a slider which represents the time interval, right? As I move the slider towards the right hand side, Olivia is going to start jogging. Now, as the time is passing, pay attention to the distance values and displacement values. As you can see, distance and displacement are both increasing. They're both increasing, right, until we reach the end point. So the distance and displacement both become 9, right? But as Olivia is returning back, here you can see the distance is increasing, because remember, distance is the total path length, right? But displacement is the shortest distance between the initial and final position of the object, and the object here is Olivia. Now, when she is returning back, you can see the displacement value is constantly decreasing while the distance is increasing and increasing And finally, when she's again at the same position as she started from, the displacement becomes 0, as she started from the house and she ended also at the house position, right? So the shortest distance between the same two positions will be 0. But the distance was the path length. So she went 9 meters and again came back 9 meters. So that means it is 18 meters, right? Let me play the animation again. So as she is moving towards the tree, both of the parameters are increasing, but the moment she is coming back, you will see that displacement decreasing, but distance is increasing, right? Again, we have another similar and a very interesting model regarding distance and displacement, right? And in this activity, we will easily be able to understand it further. Okay, now here we have an object. Okay, what we have to do here in this activity is we have to move the object through this entire path. Okay, and we will be checking about the distance and displacement values. So let us move the object. This blue dot is the object here. Let us move the object. First, the object is going to go from A to B. Now when note it properly, when it is going from A to B, what was the distance and displacement? Distance and displacement both are 60. But the moment the object is changing its direction and going towards C, its displacement and distance values are no longer the same. The distance is represented by the total length of the path that is being followed, whereas the red line is representing the shortest path between the initial and final position. That is why it is representing the displacement. Now, here you can see from point A to B and from point B to C, total distance it has traveled is 120, but the displacement is 80 meters. It is the value of the red line here, right? Let us move forward again. Another 30 meters it has traveled, right? So 150 meters, but the displacement is 100 because it is the red line, the shortest distance between the initial and final position. And when I move back to the same original position, slowly the distance becomes 250 because it is the total path length, whereas the displacement becomes 0 meters. Let us head towards some interesting brain busters. Now, students, which of the following quantities is a vector? Just now we discussed. Which of the following quantities is a vector quantity? Distance, displacement, speed, or time? Which of these is a vector quantity? Vector quantity means it has both magnitude and direction. Okay, let us look at the answer. The answer is displacement. Displacement is a vector quantity, just now we discussed, right? Let us look at another question. A person walks 6 meters east and then 8 meters west. What is the total displacement of the person? Remember students, we have to find the displacement here. That means the shortest distance between the initial and final position. Right? I'll give you some time to think about it. The answer is going to be 2 meters west. Okay, here we're talking about displacement, not distance. Okay, shortest distance between initial and final position. Okay, what is the SI unit of displacement? Is it meter, meter per second squared, or kilogram? Very easy question. The answer is going to be option number A, that is meter. Fourth question. A car moves 10 kilometers north, then 5 kilometers south, and finally 3 kilometers north. What is the total distance traveled by the car? We already did a displacement question. This one is distance question. Very simple, easy. We just have to add everything. It is 15 kilometers.